Hello and welcome to this demonstration on how to create an elastic clustering arrangement and deploy it on Amazon Web Service, courtesy of the Payara Platform. So I'm Fabio Turizo, I'm a senior service engineer and working for Payara Services Limited. And before we start, you will be required basic knowledge on two things. One, it's general knowledge of Amazon Web Service, and specific how to manage EC2 instances and the basics of network management and VPCs. You'll also be required of having knowledge on how CDI events work and in general of Java EE application development concepts as well. So you will learn today how to create a simple distributable application, and the main focus of this demonstration will be on the use of Payara's own remote CDI events. That is an extension of the current standard feature, and it's a proprietary feature of the Payara platform. You will learn how to deploy this application on an Amazon Web Service arrangement, and after that you will learn how to provision an elastic deployment by using both Payara Server and Payara Micro. Let's start by talking about the sample application used for this demonstration. So this application is composed of two main components. One is an event generator application, and this is a WAR file that is deployed in a Payara Micro instance that will be generating events. And those events will be sent to a second application, which is a web application, another WAR file that is deployed in another Payara Micro instance that is used by users or other agents in order to follow these events in real time. So this is pretty simple, right? But what we want to do is to enhance this arrangement in a distributable manner. So what we want to do is to have something similar to this. So our application arrangement is in a cluster that is composed of multiple instances of the event generator application. And the web application will only have one instance, and this still will be used by users in order to follow these events. What is interesting is that all applications combine both the web application and the instances of the event generator applications will live in the same cluster, and this is the advantage of using CDI events, is that even if there are multiple instances in the cluster, all events are actually broadcasted to all other instances in the network. But what we want to do is to have the web application to observe these events and allow users to see those events in real time. Now, let's go through the code of our application. Let's say that for the purposes of this demonstration, each event that is generated will contain some information for a satisfaction rating, for a business service of a product, as an example. So this information will be stored on a rating data object that will be composed of the score of how satisfied is the user with the service or product, a timestamp, and some comments from the user. And in place, this rating data object that implements this clustered event data, that is an interface that we're using in order to extract away any type of payload being sent on these events. The main body of every event will be this instance event data class that will contain in place an instance identifier, that means which instance in the cluster generated this event, and the data that we already observed. So every event will generate an instance event data payload and broadcast it to the entire cluster. The event generator application, on the other hand, is a simple application that contains two components. One is a message service that is used in order to access on sample satisfaction ratings, and we are doing this by using a ratings data.txt text file, which it's a single text file that contains a list of tuples of a satisfaction reaction, which is an enumeration whether the satisfaction is good or bad, and the command made by the user. So the message service will load these messages when we are trying to call this business method called get messages by reaction. So we are trying to get all good or bad satisfaction ratings, and the first time it will load the messages from the text file and will get you the result that you want. And we're using the Java's Cache API cache result annotation, as you can see here, in order to automatically cache this at runtime, and this will save us some computation power. And this message service, on the other hand, is used by the rating events generator component, which is a singleton bin that has a timer that will expire every second, and the expiration simply does a calculation of a random score, a number between 1 and 5, and if this score is less than 2 or less than equal than 2, then it will determine that it's a bad satisfaction rating, and if it's superior to 2, then it will determine that it's a good reaction. So based on that, I will generate a random event by obtaining some random data from the get random message method that will in turn call the message service that I showed you earlier. It will try to obtain all the messages by that reaction, either good or bad, based on the score that we calculated. It will calculate a random position by obtaining another random message based on the set reaction that we generated, and it will return the message string. So with the score, the reaction, and the message, then we create a rating data event, and then we fire that event. So how are we firing that event? Simple. We inject an CDI event instance here, and we are typifying by using the instance event data that I showed you earlier. And with it, we can just simply call the event.fire method, and this will fire a synchronous CDI event. Now, which is interesting here is that I'm using the outbound annotation. The outbound annotation is proprietary of the Payara public API and allows me to tell the server runtime that this event is not only contained to the JVM running this application. So in simple terms, this means that this event will be broadcast to the entire cluster. That means all the JVMs that are part of the distributed data grid, and it will reach them without issues. Finally, what I want to do when generating the event is to also get the instance name. And we do this by using another class of the Payara public API, that is the Payara micro class. This is a specific class that allows me to access any runtime of a Payara micro instance, and I do so by calling the static get instance method and then the get instance name method. And with this, I can obtain the name of the instance that is running. Of a specific interest is that I can only obtain a name that is been explicitly set up, then that's something that I will show you later. So with all this done, if I do not get an instance name, then I just simply default to Payara micro, and then that event is generated. Now, this is the event generator application. Moving on, the rating event web application, on the other hand, is a simple web application that has one component, well, two components. One is the rating session manager, which is an application CDI event that uses this specific method called observe cluster data, which is annotated with it has a parameter called the event data that is annotated with two main annotation. One is the observes. This is a CDI standard annotation that allows you to mark a component or a CDI component as an observer to CDI events. So this means that all events that are fired by the event generator application will be listened here. And here I'm using the inbound annotation. This is another annotation of the Payara public API that allows me to tell this component that it will listen to events that are coming from outside the JVM. That means these broadcasted events that we talked about earlier will be also coming here. It will be listened without any issues. So we do some validation. Okay, I want to know that the event data that I'm receiving is of a rating data. That means I'm handling satisfaction ratings, because on a production environment, on a real world example, you could be listening to any sort of event. There is no way to discriminate that based on the instance event data. So I'm using this validation of the specific data that I'm receiving. And if it is so, what I'm doing now is to broadcasting this event now using WebSockets. So I want the web application that I have here to use a WebSocket in order to notify the browser, the client code that I will be using and showing you in a bit, to map this rating data in a graph. So how you do that? First and foremost, I have this event push class that it's a server endpoint component, and this annotation tells the web container that this class will be interacting with a WebSocket session management. And what it does is, okay, I can annotate this with server component data. That means that this is a WebSocket endpoint, and it has to implement these three methods. One is the onOpen. This is a initialization method that tells the component, okay, when a new session is open, what we want to do is to get the session, register it for posterity in order to interact with it. When the session is closed, we want to register the session, and when there are messages coming from the any WebSocket that is open on the other side, we want to do nothing at this point because the communication here is in one direction. That means that we are broadcasting events from the server to the client. And when an error happens, we also want to deregister the session and log something, just to be aware of that. So moving back to the Rating Session Manager, what I'm doing here is that every time that I'm receiving a rating session data, I'm using this session map, which is a specific map instance that I'm using to register all the sessions that are open in sockets to the server. So for all sessions that are registered, I want to broadcast a JSON payload. So this JSON payload will contain the data that I'm obtaining from my CDI event. How I'm doing that? Well, I'm using the JSON P API to create a new JSON payload with these following fields: the score, the time, the message, and the instance name. And I'm passing the data that I'm receiving from the event payload that's coming from the rating from the event generator application. Once I'm done that, I want to use the sendObject method of the session or WebSocket session object, and that way I'm sending the JSON payload as a string because that's how I want it to be interpreted on the other hand. So this is pretty simple. Now, how does the client interact with this object that was broadcasted using our WebSocket endpoint? And it does so by using this JSP page here, and it contains a hard charts component. This is a JavaScript library that allows you to create visualization graphs and charts. And we're using a time series in order to showcase how the scoring of all the service ratings are going. And we're doing so by opening a WebSocket to the server here, creating a non-message listener that will just simply pass the JSON rating that we are receiving, the payload that we are receiving from the server, and call the addRating method. And this addRating method will modify the chart accordingly by adding the score if it doesn't exist, and modifying some tooltips in order to show a summary of how the scoring goes, what are the comments that the user made based on the satisfaction that they are submitting, and where the satisfaction rating is coming from. That means the instance name that we put on the event that was generated before. And that's it for the application. In the next part, I'll show you how to configure the Amazon Web Services infrastructure.